log ek is equal to log e1 by n plus log ea plus 2 by 3 log ar, because r to the power we have 2 by 3. Okay, here is a to the power we have 1, so that is why 1 into log ea, so it is nothing but you can directly write log ea. Okay, so then you have to take differentiation. You have to do the differentiation. Then you have to do the differentiation with respect to y. Okay, differentiation with respect to y. So this is again you can write here log ek, no issue. You can write log ek or ln of k, it's up to you. Okay, so again n is your Manning's roughness coefficient and it is a constant term for a particular channel, so that is why if you differentiate it will get 0. Okay, then log a, if you differentiate you will get 1 by a, and then again we know a is a function of y, as because we are differentiating with respect to y. Okay, if it is y, that is log e y, then we can directly write 1 by y, but this is not y, this is area. Area is a function of y, so that is why we have to again differentiate area with respect to y. Okay, I think you all know this thing. Okay, this is simple mathematics. So for log a, if you differentiate it will be 1 by a, and as a is the function of y, sorry, yes, this is a function of y, so again we have to differentiate area with respect to y, so dA by dy. Okay, then next we have 2 by 3 ln of r, or you can say log e of r, so it will be 1 by r, it will be 1 by r. Again r is a function of y, so you can directly write dr by dy. Okay, and we know r is equal to a by p, so I have reduced one step here by writing directly r is equal to a by p. Okay, so you can write another one step by writing here dr by dy. Okay, then you substitute a by p. Okay, it's up to you. Okay, so you'll get this expression after differentiation, and then see this will be 0, then we have 1 by a, dA by dy we have already discussed. dA by dy is nothing but our top width. Okay, you can write top width, so that is why it will be t by a. Addition twice by 3r, then this is again we have to do the differentiation using the formula uiv or u multiplied by v. Okay, it's up to you which formula you want to use, but you have to do the differentiation. Okay, here if you use this is nothing but v differentiation of u minus u differentiation of v divided by v square. Okay, this is the formula for u by v. You can use here, you will get this expression. Okay, that means u by v is your a by p. Okay, a by p means this v is nothing but your p, that is weighted perimeter, and this is your area. Okay, so first what you have to do, perimeter multiplied by differentiation of area with respect to y. Okay, then minus area multiplied by differentiation of weighted perimeter. Okay, if you solve this, let me solve for you. Okay, u by v, so this is nothing but your u by v, and in our case u by v is nothing but area by perimeter. Okay, so v is your perimeter U is your area. Okay. So this V is nothing but perimeter your multiplied by your U. That is your derivation of U. U is area. So it will be dA by dy. Okay. Then minus, then it will be area. Okay. Then multiplied by V dash. That is differentiation of V with respect to Y. So dP by dy. Okay. Then divided by V square. That is divided by P square. Okay. If you further solve, this is P square. Here we have P. One P will be cancelled out. So what will be left out? 1 by P dA by dy. Okay. dA by dy. Minus, here we have A by P square. Okay. So this is area divided by P square, and it will be dP by dy. Okay. So this will be final expression. After you differentiate this A by P, you will get this expression. Okay. 1 by P dA by dy minus A by P square dP by dy. Okay. So here you can see that expression. Okay. And then we have 2 by 3r, so it will be a constant term. Okay. Afterwards, we are going to multiply. Okay. So next line, T by A will be remain same. Then we multiply it by 2 by 3r. Okay. First we multiplied with this term, then we multiplied with this term. Okay. So we have P is here, we have R. R again we can write A by P. This P will be cancelled out. Okay. By 3 R in place of R, we write A by P. And then dA by dy we can write top it. Okay. We have already discussed. Okay. Minus, again we multiplied 2 by 3R with this term. So 2 by 3 in place of R we can write A by P. Here we have already A by P square. Okay. So here it will square and this P will be cancelled out. Okay. This area is also cancelled out. Okay. Let's see what will be the next expression. Okay. So this will be same left hand side. T by A will be there. Then this P will be cancelled out. It will be left out with 2T by 3A. Okay. Minus this A is cancelled out. This square and this P will cancel out. So it will be left out with twice by 3P. Okay. 2 by 3P dP by dy. Okay. So this is also T by A. This is also 2 by 3 T by A. So we are going to add both. Okay. And we will get 5T by 3A. And other terms are remain same. Okay. And we consider this equation as number 3. Okay. So we got our equation log E k d by dy equal to n by twice y. This is our equation number 2. Okay. We got our equation number 2. that dy log e k is equal to n by twice y. So our intention is to find an expression for that capital N, which is a hydraulic exponent. Okay. So here also in equation number 3, that left hand side is same. Okay. So now what we do, we are going to replace this left hand side in equation number 3 by considering equation number 2. So next we are equating equation 2 and 3, and we are going to replace that d by dy log e k by n by twice y, okay, in equation number 3. Then we multiply it with this 2 and 5 with 10. Here will be y. So then yt divided by 3a, and then again we multiply twice y with this term also. Okay, then it will be 4 and y will be there. So it will be 3 area. So this we have considered one area as denominator and one is numerator. So if you consider this two, again it will be cancelled out and we will get this step again back. Okay. So why we did this? To bring R. Okay. To bring that radius or hydraulic mean depth. Okay. So it's up to you. You can bring R also. If you don't bring, then also it's correct. Okay. It's up to you. So it will be 4y by 3a R. Okay. So this is 3a and this is 3a. We will bring it out, that 3a, and we bring it out twice y. So twice y by 3a, left out will be 5t minus twice r dp by dy. Okay. So we consider this is as equation number 4, which is our general equation for hydraulic exponent using Manning's equation. Okay. So you kindly go through the derivation and see if you have any doubts or not. Okay. And if you have any doubts, then we can discuss here. Okay. So once you go through the derivation. Okay, so this is the general expression. Then we can use your channel is trapezoidal. Then we can find out what will be the n value when the channel is trapezoidal. Okay, then rectangular, then white rectangular, okay, and so on. Okay, depending on the shape of the channel, this n value will be vary. Okay, so we have just left out with one topic, and after that we are going to complete this unit number 1. Okay, then we will move on to the next unit, that is your canal design. Okay, so next topic you write shear stress on the boundary. Okay, next topic is shear stress on the boundary, and you write this expression. This is nothing but your shear stress is equal to specific weight. So in place of specific weight, you can also write rho multiplied by g. Okay, density multiplied by acceleration due to gravity multiplied by r. What is r? We all know, and then we have to multiply it by bed slope. Okay, so shear stress is equal to rho into g, or you can write specific weight small w. Okay, multiplied by r, hydraulic radius, multiplied by bed slope. Okay. Then you can write where you can write this thing. Okay, tau is equal to shear stress. Small w is a specific weight. Okay. Then you can write this. Okay, this is record boundaries here in the uniform flow. The term root over is nothing but your shear velocity. Okay, or you can also write this expression as u star is nothing but your shear velocity. So this is your if we root over shear stress divided by density, it's give you your velocity. That is your shear velocity. Okay. So here shear stress is nothing but your specific weight, that is your rho into g, multiplied by r, that is hydraulic radius, multiplied by sb. Okay. And then we have divided by density, root over. So this is your nothing but u star. That is your shear velocity. This density will be cancelled out. So it will be left out with acceleration due to gravity multiplied by r multiplied by sp. This is your u star. Okay. So this is the expression. Dimensionless and used in pipe flow. Okay. Another resistance coefficient called Darcy's coefficient. Okay, of friction small f, which is dimensionless and used in pipe flow. Okay, used in pipe flow. According to some hydro Darcy's coefficient may be used. Okay, so the this was given by some scientists which those who are working on hydraulics. So they have also said that the Darcy's coefficient can be also applied to the open channel flow. when the pipe diameter is replaced by 4 times of the hydraulic radius r. Okay? That means the diameter is d. If we replace the diameter by 4r, we can use Darcy's coefficient also. Okay? As a friction. So here we all know HF equal to FLV square by 2GD. So they are talking about this D, okay? This capital D, in place of D, we can write 4R. Okay? You can write these expressions. So these things are not much important. This is important. Derivation is not in your syllabus, okay? This thing's not in the syllabus, but for your reference, you can write it down. So basically, we are going to try to derive an expression for v square. That is your velocity. Okay. From here, in this equation, in place of d, we substitute 4r and we try to find the expression of v square. So this is the expression we are getting finally. Okay. So these things we have already considered a constant c. Okay. So friction g8. So we consider a constant term. So those things are not required. You can directly write down this expression, relationship between your velocity and n. Okay. So this is important. And these expressions are also important. Okay. To solve numerical this and this. U star is nothing but your shear velocity, then divided by velocity is equal to Manning's n root over g divided by r to the power 1 by 6. Right here, U star divided by velocity is equal to root over g divided by c. Because we know c is equal to r to the power 1 by 6 divided by n. Okay, that relationship I have already gave you. Okay, that is why r to the power 1 by 6 divided by n, if you bring n is here, so you can directly write c. Okay. So this constant is equal to r to the power 1 by 6 divided by n. Okay. And this is nothing but your shear velocity divided by velocity is equal to root over g divided by c. Okay. And in place of c, we can write r to the power 1 by 6 to the power n. Okay. So using those equations, we are going to solve one numerical. Okay. So this is the last numerical for this chapter. So what is given is a trapezoidal channel with bottom width of 2 meter. You please write down the questions. Okay. with a depth of flow is given 0.5 meter, slope is given, Manning's n is given. Okay, side slope is given 1 is to 1. That means our z is equal to 1. Okay. Then what we need to find? Find shear stress. That is nothing but your u star. Okay. Sorry. Sorry. Shear stress is not u star. It's tau. Okay. Tau not. Shear stress. Then you need to find out shear velocity. That is your u star. Then we need to find out shear is constant. Then Darcy's coefficient of friction, that is smaller. Okay. This is so here shear stress we all know specific weight multiplied by r into slope. Okay. Shear velocity root over tau, or you can say shear stress divided by density. Okay. As Manning's n is given, to you can find out this stress is constant, that is r to the power 1 by 6 divided by n. Okay. And Darcy's equation, you use Darcy's equation to find out the smaller 4 FL v square by 2 ZD. Okay. So you start solving this numerical. Okay. First you find out the shear stress. Okay. So shear stress is nothing but specific weight multiplied by r into bed slope. So this is specific weight is rho into g, then r into slope. Slope is given, g we know, density also we know. Then we need to find out first r value. So r is nothing but area by weighted perimeter. So these things you already know. Area of a trapezoidal channel. You see area you are getting the same or not. 1.25 meter square. Once you find out area, then we have to find out the weighted perimeter. Okay. So again, for weighted perimeter, we have to consider this side, this, and this. Okay. So if you remember, this is our y, this is our zy. This part is nothing but your width of the channel, and this part is again zy. Okay. So those things you have already calculated. Okay. So you find out area and perimeter, find out the r value, and you substitute the r value here and determine shear stress. Okay. You'll be getting around 1.76 Newton per meter square. See here in a specific weight that the rho into g density depends on about the unit. Okay, you may consider 1000, then you have to take meter cube, sorry, kg per meter cube. Okay, kg per meter cube. Okay. So 1 Newton is nothing but kg meter per second square. Okay. This is 1 Newton. So stress we always write in Newton. So try to get that Newton per mm square. Okay. And see you are getting the same value or not. If you consider 1, so 1 gram per cc, then it will be centimeter cube. Then again you have to convert into meter because the other parameters, your hydraulic mean depth or you can say hydraulic radius, it is in meter. Whatever you are going to get, it is in meter. Okay. So this meeting is going to end soon. Okay. So you kindly write down the answer for shear velocity and you solve of your own and see you are getting the same value or not. For shear stress is 0.042, says it's constant 56.23. Okay. And you can use this equation for Darcy's coefficient of friction. Okay. C is equal to root over GY. So from next class, we are going to start the second chapter, our canal design or channel design. Okay.